This is the 6.2a video. We're going to look at describing the effects of adding or subtracting a constant or multiplying or dividing by a constant on the probability distribution of a random variable. So this is actually going to be quite similar to what we've done in chapter 2 where we transformed distributions. Now we're going to transform probability distributions. And you'll see that the same principles apply. So let's look at a simple example that we used in chapter 2. So let's say we have a distribution, we'll call it F, and the outcomes are 1, there were 2 2s, and there's a 3. So first I'm going to add a constant. I'm going to add 2 to all the values and see how this distribution changes. So if I add 2 to each of these observations, then you can see the mean was 2 and now it's increased to 4. So the mean is just increased by 2. And the spread, or the range I should say, was from 3 to 1, which is a distance of 2, and now it's from 5 to 3, which is still a distance of 2. So remember, adding a constant doesn't increase the spread or any measure of spread in a distribution. All that it changes are points of location and the measure of center. I'll talk about that in a second. Next, let's go back to F, and now let's multiply this, or every observation, by 2 and see what the distribution looks like afterward. So now if I've multiplied every observation by 2, you can see that the lowest value, 1, now becomes 2, and the largest becomes 6. So the center of this distribution is now at 4, so it's been doubled, went from 2 to 4, and the spread has also doubled because now the range goes from 2 to 6, which is a distance of 4 when it used to be a distance of 2. So to summarize what we can take away from adding constants, whenever we add constants, measures of center and location change, but measures of spread do not change. When we multiply a distribution or a random variable by a constant or divide, then the measures of location change and the measures of center change and the measures of spread change. So everything changes when we multiply, except the shape has never changed. You can see it still looks symmetric here. It looks symmetric here. It's just more spread out. So I'm going to write out the different measures of location, center, and spread over here on the right side so you can be aware of what they are. So the measures of location, percentiles, would be like the 75th percentile. Now it's increased by whatever we've added. Quartiles, percentiles are, well, quartiles are specific percentiles. The min and the max, those will change. Those are measures of location. Centers are also technically measures of location, but I just wanted to identify them as center as well. Our measures of spread are range, standard deviation, IQR, and variance. So these measurements of spread will only change if we multiply or divide a distribution by a constant. So now let's apply this to a random variable. And this random variable is going to be Pete's Jeep Tours. So Pete offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. Define X as the probability, as the number of passengers on a randomly selected day. So this is a discrete random variable because we can list all the possible outcomes. It has to be 2 and a maximum of 6, and you can't have part of a passenger, so it's got to be 2, 3, 4, 5, or 6. So he's figured out the probabilities of those outcomes occurring. They want us to first identify the random variable X and find its mean and standard deviation. So we'll do this using our calculator. So first I just want to identify that X is the number of passengers on a randomly selected day. Because when we're working with random variables, we might have a handful of different letters to represent the variables. So we want to make sure we remember X is the number of passengers. And you can see there's a histogram distributing this probability distribution over to the right where it's got the number of passengers. So we could kind of estimate what we see the mean is. But I want to use our calculator and punch it in and get the exact value. So to find the mean and the standard deviation, I'll put the outcomes in list 1 and their probabilities in list 2. So I should have said earlier that before I did any of this, I should make sure that it is a probability distribution and add all these probabilities together and should equal 1, which it does. So now let's find the mean and the standard deviation. I would stat, calculate one variable statistics. My list is list 1 and my frequency list. I need to make sure it says list 2. So I'll calculate, and you can see the mean or the expected value is 3.75, and the standard deviation is 1.0897. So you can see I've transferred over from the calculator. The mean is 3.75 passengers, and the standard deviation is 1.0897. So if we interpret this, the mean, if we randomly selected many, many days, on average, we'd expect them to have 3.75 passengers. And the typical difference would be 1.0897 passengers from the mean, interpreting the mean and standard deviation. If they asked us what the variance was, all we would have to do is square this value to find the variance. So we have our random variable x. Now we are going to conduct our first transformation. So suppose Pete charges $150 per passenger. The random variable r describes the revenue Pete collects on a randomly selected day. So now, to figure out how much revenue he's going to draw on based on the passengers, if he makes 150 passengers and he has 2 passengers, then he makes $300. So the first possible outcome is $300. The probability of him making $300 is the same because it's based off the probability of him getting 2 passengers. So all we're going to do is multiply every outcome by 150, and their probabilities are going to stay the same. So now we have the new distribution for the random variable r. Let's define what the random variable is in terms of x. So all we did was multiply every outcome by 150. So if r is the revenue that he makes, then it's going to be the number of passengers times 150. So r is the revenue collected on a random selected day, and we multiplied the previous random variable x by 150. So now let's find the mean and the standard deviation. So you should already know, if I'm multiplying, then the distribution, the previous distribution of x is going to be more spread out by 150. The mean is going to increase by a multiple of 150. And the shape is going to be the only thing that isn't going to change. So if you look over at this distribution on the right-hand side, you can see they've already done the transformation. They made a new histogram of this probability distribution. And in the previous distribution, the range was from 2 to 6, but now the range is going from 300 to 500. So that's why we're saying it's more spread out. It's not from, it doesn't have a spread of 4 now. It has a much larger spread because we've multiplied it. And you can see the mean is now going to be in the center here, which is much higher than it was previously. So we could just take this mean and multiply 150, and we could take the standard deviation, multiply 150, which is what we'll do. But I want to show you on the calculator that we'll get the same exact values. So let's punch these now into our calculator and see what the mean and standard deviation are. So I'll put our new values into the calculator and see what the mean and standard deviation are. So I've got the different amounts of revenue and their probabilities. Let's calculate the statistics. So here it shows that the expected value is 562.5 and the standard deviation is 163.459. So remember these values while I click back to our notes. So you can see I've copied the mean and the standard deviation from the calculator. But I want to show you that you don't have to use a calculator. You can just use, you can find the mean and the standard deviation of the transform random variable that's multiplied by 150. Since multiplication increases the points of location, center, and spread, I'm just going to multiply the mean of x times 150, and that will give me the mean of r. And so 3.75 was the mean of random variable x. Multiplied by 150, you get 562.5, which is what was shown in the calculator. Now let's do the standard deviation. Since standard deviation changes when we multiply, we're going to do the exact same thing, multiply the previous standard deviation by 150 for the new standard deviation. And so you can see we get the exact same value from the calculator just by multiplying. So really just remember, when you multiply, and so this is summarized here, when you multiply a random variable or a probability distribution by a constant, the measure of center and locations change, and the spread changes by whatever you multiply by. But the shape does not change. So now let's look at an example of adding a constant. It cost Pete $100 to buy permits, gas, and a ferry pass. The random variable P describes the profit Pete makes on a randomly selected day. So we had the random variable X, which was the number of passengers selected on a random day. We had a random variable R, which represented the revenue he made on a randomly selected day. Now we have P. So P is the profit, which profit is just the revenue minus the expenses. And you can see his expenses are $100 per day or per trip. So we can define the random variable P as R minus 100. So if you remember from the previous distribution, his revenue is 300, 450, 600, 750, 900. So we'll subtract 100 from each of these because that will take out his expenses of buying the permits in the past. So now you can see I've got P as the profit on a randomly selected day, which is just the revenue minus 100. So that's what I've put in these slots here. And the probabilities stay the same because they're all based on the number of passengers. So just like the previous example, I'm going to throw these into the calculator, calculate the mean and standard deviation, and then show you how to do it by hand. So you can see I've got the profit and their probabilities. Let's calculate the mean and standard deviation. 462.5 and a standard deviation of 163.46. So you can see the mean of the profit is 462.5 and the standard deviation is 163.46. You should remember that this value is exactly the same as it was before because subtracting a constant doesn't change the spread of a distribution. The standard deviation is a measurement of spread. So now I'll work it out by hand real quickly, and this is the way I prefer you to do it in class. So here you can see, instead of using mu, because the other symbol for the mean is the expected value, the expected value of the profit is the expected value of revenue minus 100. So I subtracted 100 and I get the expected value to be 462.50. Standard deviation, the only symbol for standard deviation is sigma. And so I'll write out how to find the standard deviation, but it's really simple because the standard deviation doesn't change. If I'm subtracting 100, then the standard deviation of P is just going to be equal to whatever the standard deviation of R is, which is 163.46. So let's look at our last example. And the last example is a linear transformation where we're going to use these exact values actually, but we're going to conduct the multiplication and the addition at the same time. So just a reminder, when we subtract, it adds or changes the measures of center and location, but it does not change the spread, as well as it does not change the shape of the distribution. So for this last example, for this linear transformation, what we did is we converted Pete's number of passengers to his revenue and then used his revenue to find his profit. But we could have found his profit straight away if we just multiplied the number of passengers, which was X, times 150, and then subtracted the 100. So this is a linear transformation, it includes the multiplication and the subtraction. And it's quite simple. We're just going to do the exact same thing where the multiplication will change measures of location and spread, but the subtraction is not going to change the spread. It will only change the measures of center and location. So if you remember from the first problem, Pete's expected passengers or his mean amount of passengers was 3.75. So since multiplication changes the mean and subtraction changes the mean, we're going to do both to find the new expected value or mean. And you can see we get the same expected value for the profit. But when I write out the standard deviation, I will leave off this 100 because the subtraction of 100 doesn't change the measure of spread. And so if you remember from the first problem, the standard deviation of the number of passengers was 1.0897. So we'll multiply that by 150, leaving off the subtraction because the subtraction doesn't change the spread, and we get the resulting profit or the standard deviation of the profit. So even though for these examples, I typed them into the calculator, I don't want you typing them in the calculator. All you have to do is do the algebra here that you've seen. And I want you to take a look at these. There are 3 independent practice problems that I want you to work through for different scenarios.